You are given an array of length and consists of 1 and minus 1. You may perform the following operation: a of on a operation on a any number of times. Choose an index I satisfying assign a equal to minus and plus equal to also minus. Determine whether it is possible to make the sum of element of a equal to 0. So it gave me yes. It said to make it minus. It didn't say multiply with minus. Actually, it's same actually, yeah. In the fifth test case, minus minus becomes 1 1. Yeah. One, 2, odd number 3. If I have some values, 1 2 3 4 5 6 7 index. If I modify this to they changes, there's some pair. How many values? Only 100. Let's just think of it. They'll be fixed actually. No, they're not fixed. It can be changed. It also can be changed. This one depends on X disable. The values is only 100. I can do some brute force that. Minus 1 1 minus 1 minus 1 minus 1 1 minus 1. They cancel out. To make some pairs. Yeah. I think I shouldn't overthink. Let's go with the gut feeling. Let's try it. Okay, there's a case. Let me think. Let's say 1 1 1 1. Okay, I can do this operation. Yeah, that's possible. there's little bit chance it will make it wow, but let's see what happens. Wrong. So I need to equalize. Okay. -1, 1, -1, -1, and something like that is the case. Okay. See if I switch them up. 1 -1, then -1 -1 equals to 1 1. Equals to 1 1. Okay, so 1 1 -1, still one less. Even, yeah, it makes sense. It does make sense. There is another case. If that's equal to 2, I can't change anything. Number of pairs should be exchangeable. Nice. If to 0 and zero and get up then 2. No, yes, no, last one got 1. Somehow it's getting accepted. -1 1 -1 -1 -1 -1. 6 values, both are pair, and it got nothing. Okay. So if I pair them up, I need 3 actually, yeah. Oh, it does make sense. Really? Wow. Should I do a brute force? Oh, actually, 5 minus 1 is 4. It should be by 2. It's a by 2. It's 4. By 2, by 2. Yeah. You are given three integer n, k, m. We call an array a of length n consists of positive integer good if the minimum length of a non-empty subarray of a which sum is divisible by m is equal to k. Nice. We call an array of length n consists of positive integer good if the minimum length of a non-empty subarray a which sum is divisible by m is equal to k. Okay. Formally, an array is good if the following condition holds: there exists an LR such that L minus R plus 1 equal to k, and sum of length is k and divisible. Okay, there does not exist length LR, there does not exist LR less than k and divisible by m. Find the minimum, find any good array of determinants such exist. Okay, so I have nkm. Five, 3, 5. It's given me 9, 17, 14, 23, 11. In the second case, 9, 17, length 3. Length 3, 5. 9, 17, and 14 equal to 40, and 40 is divisible by 5. Okay, nothing less than exists. Okay, 118 up to 118. Okay, and can be 3, 5. So when is it gonna be no? 6, 4, 3. Full length x, and something. Okay, 4 length divisible by 6, divisible by 6, length 4, sorry, divisible by 3, length 4. So 3 3 3 3. Okay. Less doesn't exist. Okay, something less doesn't exist. Something mod 1, 3 mod 1 2 3. Okay, it makes sense, it doesn't exist. This one was divisible by 5, so I got what's the mod value? 4. What is the mod value? Mod value is 2 4 8 10. Yeah. Okay. And other segment doesn't create a sum. Okay. So I have to repeat something. Let's say I put in mod 1 2 3 something 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 up to m minus 1. Okay. If I put 1, no. Let's say I'm putting something like mod 1 1 1 1, then mod 1 2 3 4. Adding them up is 4. How much I need? I'm gonna add that here. Okay. And I have to put something. What if I put something in here? If those are ones, let's say I need 2. Okay, let's say I need 2. So I'll just put, if I put 3, if the value is 1 2 3 4 5 6, so 6 is the target. So if I put 3 4 5 6, I'll get that, so that's the problem. If I put 1 again, 1 1, yeah, I can put repeatedly put 1. What was the K and M? NKM. Input is NKM, yeah. The length that much, so 1 2 3, yeah. So it can be at max m minus 1 length if k greater than equal to greater than m. Ouch, no. Else. Yeah. greater than or equal to, both are problem, because let's say length 5 mod 5 something is 1 1 1 3 4 3 4 5, so I can put 2. Less than equal to n. Length, it's same, right? Less than n. Then just see out number of length is, so k minus is 2. I got some 2, but I need 5, let's say. So 5 plus 2 is 7. Now 2. I just need 3 actually. See out m minus k minus 1. First one gave me no suddenly. 1 1 1. If both are equal, 1 2 3 4. Equal is possible. I was wrong. One minus I'm gonna have to check. Okay, you are given two array A and B of length and consist of 0 and 1. You may perform the following operation. Any operation on A any number of time. Choose k index, k indexes where between n and sum of 1 to k is odd. In other words, choose non-empty subsequence of a with an odd sum. For each j, set ai equal to 1 minus, that will, in other words, inverse the subsequence. Find the minimum number of operations need to transform a into b, or determine that is impossible. Okay, I have this 0 and 1. I can choose a to b. Okay, is k is given, choose k index somewhere between 1 to okay, everything to some, oh, that makes sense. Minimum number of operation, so 1 0 1 0 0 1 0 1. Okay, everything is different. No match, no match, no match, no match. Sum is odd. Okay, sum is odd. That's problematic stuff. So 1 2 3 4 is the index's sum. Oh no, the sum. 1, that's the even, so 1 2 3, and next one for this one, so answer is 2. Why this one is impossible? Let's see. 1 0 1 0 1 1 1 1 1 1. So 0 0, they becomes 0 1 1. Oh, makes sense. Removes the dependency. So intuition is answer can be 0 1 2 or minus 1. Okay, there can be two possible answers. I have to check another thing. Is it it's back to square one. Think a little bit. If there was another one, I can choose all three. It becomes 0 1 0 1 0 1. Okay, it's right on the bottom. 0 1 0 1 0 1. Okay, and I have those. Let's select all of them. Let's select two of them. So 1 0 1 let's select all. Okay, there have to be at least one. If the answer had 1 0, then it will be possible. It's possible. All 0 is always possible. All 1 is not always possible. And yeah, into operation. If the values are all 1s, I can make all of them 1 and 0, 1, 1, 1, 1. And this 0 is the problem. It's not possible. What if I have some zeros? Okay, let's make them up 1, 2, and everything matches. There's 2, so I need to operation even. Actually, the 0 doesn't count at all. It had 1 1 0 1 1 1 0 1 1 1. Okay, if all values are 1, no matter what, if there's no matter what, it doesn't work. 1 operation, 2 operation, 0. It doesn't matter actually. If everything is 1, if there was a single 0, I could just do, I can make it 1, yeah, no matter what, I can make it 0. Or if everything is 0, I can't do any operation. If those are not equal to, and down Okay, there are several conditions. At first, there has to be at least one to do some operation, otherwise it's impossible. Okay, second condition is if I change do some operations, the answer B has to have some at least one zero, otherwise it has to be same, exactly same. It has to have one, otherwise no. Second option is if it has some mismatch but no count, then answer is equal to at least 2. And with mismatch, it has to have at least 1 0 in the answer. It means it has some zeros. Count if okay and okay, if those are same, it will gonna return 0. Okay, so 0 is done. Now case 1. If I have some count, if count mod 2, count and 1, and if I have some counts, that's the odd count. Okay, if that's the odd count, total count is odd. If total count is odd, so doing operation is possible. Yeah, count, if count is odd, it's always possible, I guess. Now depends on two operation. Okay, if count is even, count is even, I means non-zero even, also it's always possible, I guess. Two value has to change, at least two will have to change. If count return to. Okay, now the next case. I have some 1, 1, 1, then 0, 0, 0, 0, 0, 0. Okay, sorry, 0, 1, 1, 1. Okay, let's put a 0. Yeah, 1, 1. Okay. First operation, I'm going to do something like all ones, 0, 1, 1, 1. Then to revert it back, 1, 0, 0, 1. Sorry, 1, 1, 1, 0. So I will take two operations. So in this case, I have to have the string B has to have a 0, and yeah, B has to have a 0. Okay, if I have at least one here and at least 1 0 here, it's possible. Okay, if all of them are 0, what will gonna happen? If all of them are 0, it's still possible actually, because I can just make it 0. If that happens, 0 0 0, it gives me directly the fast case actually. I think it should work. Else failed. Okay. Shoot. Okay, passed. Let's see again. If I got an odd amount, it's okay. If I got an even amount, also okay. If I got a 1 and a 0, it's still okay. If otherwise, it isn't okay. There is a slight chance it will gonna get WA, but it's really low, I guess. I don't think it will gonna get WA until it passes. No one can say it. Yeah, it looks like it's AC. Okay, for an array B consists of m positive integer define FOB as follows. Okay, and for a non-negative, yep, nice. For an array B consists of m positive integers, define FB as follows. For a non-negative integer k, we say that B can be k sorted if it can be sorted in non-decreasing order by performing the following operation any number of time, chose to integer ij such that less than equal to k. Note that the condition applies to the index ij, not the element. Okay, swap the element of b and bj. The value FOB is defined as the smallest non-negative integer case such that the array can be sorted. You are given an array of length and consists of positive integer. You will perform q updates on A. Each update has the following from ix assign A equal to x. Note that the updates are persistent. In other words, each update affects all subsequent state of the array. For each of q plus 1 state, A is okay. You are given an array of length and consists of positive integer. You will perform q updates on A. Each update the following from ix assign. Okay, just update. Okay, note that the persistent in the word. Note the update are persistent. In other words, each update affects all subsequent state of the array. For each of the q plus 1 state of A, the initial state and the state after each query update, find the value of f of A. Find the value of f of A. Update, where is the update? N and q, the length of the q equal to 0 in this case, okay, no update. N a0 up to n minus 1, okay, the j follows I. This update means it is greater than the okay, for output q plus 1, okay, so 0 updates. Two, three, four. Okay, answer is 0. It's already sorted. 2, 5, 3, 4, 1, 6. Okay, if I sort this 1, 2, 3, 4, 5, 6. Okay, minimum case 4. Minimum case 4. So it said I XOR J less than K. 1, 2, 3, 4, 5, 6, 7. Okay. So if I XOR some adjacent values, what is gonna happen? 1 and 1, 0. It will increase to 2, 3. Okay, it feels really hard actually. 2, 5, 3, 4, 1, 6. Okay, let's say I know the answer is 4, 1, 0, 0. 1, 2, 3, 4, 5, 6. 2, 5, 3, 2, 5, 3, 4, 1, 6. 2, 5, 3, 4, 1, 6. 1, 2, 3, 4, 5, 6. Yeah. Where's the XOR? XOR is 3. It's on its place. It's on its place. So those values are the problem. If I see the adjacent value, what's the length? Length is what is the constant of n? Ten to the 6. 1 and 2 is 3. 1, 2, 3, 4, 5, 6. Oh, it's written already. 1 and 5 is 1, 0, 0, 1. So removing 1. So okay, and I can also group them up. 1, 0, 0, 1, 1, 1, 0, 1, 0. So 1, 1. So also yes. So they can be grouped, and they can be grouped, so easily sorted. For adjacent values, if I do XOR in the large scale, it's always not good. Let's see. 1, 2, 3, 4, 5, 6. 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0. 5 is 101, 6 is 110. Okay. Let's do 7, 111. Let's do 8, 1000. Okay. With it, it's obviously gone. If I do close operation, it will not exceed 3. Also not exceed 3. If I do this operation, removing 1, it will not exceed 1, not exceed 3. This part isn't sorted, so 3 is allowed. Just have to make the maximum valid groups. 1, let's have 1 is 0 1. Okay, I have, let's say, 1 0 0. So 1 can obviously merge with anything with this value high 1. 1 can merge with so lower than 4 up to 4. One, two, three. If I group them up, they'll never produce anything greater than 3. So if I just divide them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So they will not produce anything greater than 3. Let's say 1, then 3, then up to 7 is what? 7 is the max, up to something, I think 15. Yeah, it goes something like that. So if I choose 3, up to this point everything is safe. Okay, up to this point everything is safe. Now the unsafe part. Let's say I want to make 4, maximum 1 0 0. Okay, let's say 5 isn't in the perfect position. One zero one. I just can merge with this value is extra, this one is extra, so I can say, yeah, I can merge with 1 and achieve my goal. Yeah, I can merge with 1. So 5 is in the group. Yeah, it's that simple, I guess. bro. Okay. Non-negative integer k. Yeah. K can be up to what? Let's make it 1 in 9. It's not a problem. Okay, so largest bit, next largest bit. Up to next largest bit, okay. So Or AI can be up to 1 in 9. That position is marked. Position is marked. So 10 to 6, 7, 8, yeah. I just marked the position, okay. This position, those positions can be swapped, okay. If the values are not equal and dot second, that position both position are not marked. If values are not equal, or any of the position is not marked, then return 0. Okay, 4, and one, yeah. If I make it 5, if okay, meet n, it was the minimum, okay. So and equal to meet minus 1, start equal to meet plus 1. Gave me 0 on case 2. Why it gave me 0? it start from 0. Still answer is 0. Oh no, it's correct. Zero, zero, zero. Still got 0, 0. Are my sorting is wrong? Sorting is correct. So from index 1 I'm saying if both are not equal and any of them is wrong, obviously both are wrong and both are not equal. It didn't print. I returned 0. Did it really return 0? It doesn't print. Okay, so obviously it's returning 0. So something wrong in my binary search. Nothing. For 1 I get 1 and 2. If I XOR them, it will gonna be 3 actually. In 0 it's not possible. In 1 it's not possible. In 2 it's not possible, in 3 it should be possible. Answer is still 0. Why put in 0? It should be 1. So this line is useless actually. What? Yeah, makes sense. I think I should change my logic. The question is zero indexed. Nice.
4,000.
Oh, something weird is going on. Why it's getting -1? 61 minus, wow. Yeah, my logic is flawed actually. There can be adjacent zeros. My target should be adding, let's say, those zeros somehow, if they are in the same. Finding out the path actually. That's too late, but let's give a simple, yeah, let's give another try with a simpler way.